name is Anna Timbenzel. Welcome back to my channel. We are going through as many LeetCode problems as we physically possibly can in a year, and we are on question number 77, combinations. Now, I don't remember doing this problem, but apparently I did it August 1st, which would also track because I tried to do the same thing with the LeetCode as I tried to do in August, but it was right around my birthday, so I wasn't able to keep track and buy the tickets. But like I said, I don't really remember doing this entirely, but apparently I did pretty well. So let's go into this solution and why it works. But before we do that, let's go ahead and start with the question. So given two integers n and k, return all possible combinations of k numbers chosen from the range 1n. You may return the answer in any order. So I want to jump in here and say that I started this by using a backtracking algorithm, just because to me that made the most sense, and it was based on the pattern. It would be the path of least resistance to not only find but also store all of the possible combinations. So breaking this down, we have here a backtrack function, which is set with this initial value of 1 and an empty list path. Inside of this function, essentially, there is a base case, so that if the length of path is equal to k, then it means that we found a valid combination for the k elements. So we append the copy of path to the combinations list using path. And this is a necessary step. Because we don't want to append the references of the same list every time. We need a deep copy to store the combinations. So that is the main work of that generation combinations done there. Then we go into a loop that iterates from the start to n. So here we have the start to n. For each value I in this range, we consider it as a potential candidate to be part of this combination. So we append I to the path and the path list to include it to the current combination. And then we make a recursive call to backtrack with an update from the start value of I plus 1 and the current path. So after the recursive call, we pop out the last element of the path and list the path list to backtrack and explore other possibilities. So this process just continues until all of the valid combinations of length k are found, and after the backtrack function completes, the combinations list contains all of those valid combinations and it's returned in that final result. So that is my approach with this one, and it did really, really, really well. I think one of the reasons it did as well as it did is because the base case that we had basically just ensures that all valid combinations are added to the results list. And the recursive backtracking process that explored the different combinations until all of the possibilities were exhausted is done in a way that optimizes this as a whole. So the submission what beat 100% of users who use Python and 100% of users who use Python in memory and runtime. So overall, this was probably one of my top two solutions. I had this with another one also, but I will put this in my GitHub repo, which is linked down in the video description down below. And if you guys have any questions about why I chose this, and I'm hoping I'm making it clear onto why I chose this and how I broke it down and created this solution. But you guys are more than welcome to fork and clone. Make it better if you can. Like, seriously, if you can beat 100% and 100%, and like my runtime and memory, like if you can make this, if you can do it better, please. And if you want to learn something, make it better, make it worse, have some fun, learn something new. And I will see you guys in the next video. Thank you so much for watching. Goodbye.